Okay, this is the cumulative practice test for the last test, and it says Nancy has $5,000 to invest in two different accounts, one 7% and the other is 8.5%. She wants her income, or in other words, her interest from these two investments for 1 year to be $400. And how should she invest the money in these accounts? Well, anyway, we don't know how much is in the 7% account. We don't know how much she should invest in the 8.5% account, but we do know that the total is $5,000 that she puts in these two accounts. So we call X the amount that she puts in this account and Y the amount she puts in this account. So X plus Y equals 5,000. And the other equation is based on the interest. So 0.07X plus 0.085Y equals $400. And that's a linear system of equations. And to solve that, just go to your linear system and put in your coefficients. 1, 1, 5,000, and 0.07, 0.085, 400. And we get that solution right here. That means that she should put $1,666.67 in the 7% account and $3,333.33 in the 8.5% account. And that would be that problem. On the second problem, it tells you about a person has $150,000 to invest into three different accounts. So there's the interest rates. And here's the interest that they want to earn from these two accounts, and the amount allocated to the last two accounts is $30,000. So that's a system of three equations and three unknowns, and you can solve that right here in this area with 1x, 1y, and 1z has to add up to $150,000. Your interest rates add up to the total amount of interest of $16,000, and then the last two accounts totaled $30,000. And this would be the amount that you should invest in the 12% account. $10,000 right here is the amount should be invested in the 8% account, and $20,000 should be invested in the 4% account. On problem 3, as soon as we get back there to it, and the computer catches up, let's see if we can do this again here. Taking some time to get caught up here. Almost there. There we go. On the third problem, it gives you two equations, one for the value of a Pentium computer, this one right here, the negative 50T plus 2400, and this linear equation for the value of an AMD computer. And it wants to know in how many months must the two computers be on the market until they have the same value, and what is that value, and explain how you got your answer, and then show the answer graphically. Okay, well, these are two linear equations. I could use that linear sheet if I wanted to, but these equations would have to be in the right form. I would have to take the negative 50t to the other side to get 50t plus v equals 2400, and I would have to take this negative 40t to the other side to get 40t plus v equals 2000. So I could do that if I wanted to on this linear sheet right in this area here. I forget for sure what I was saying there, 50t, and I think, what was it, 1v equals, I forget what it was, 2400 maybe, and the other one was something like a 40t, and 1v equals 2000. I think that was it. I forget off the bat, but that was it, and this would tell me amount of months. 40 months, it'd be worth $400. Another place you could solve that system of equations is on the nonlinear sheet, because really the nonlinear sheet does every sort of problem, including two polynomial equations, and linear equations are just polynomial equations. So I could go to this area, and now this is set for me to put them in the right form. So this was the Pentium computer, negative 50t plus 2400. It was solved for the dependent variable, so it's ready to go. Notice I put this in where d is, because d is the a coefficient in front of the linear term of x, negative 50 plus 2400, and I put in the AMD one over here on this one right here, negative 40 and 2000, and then just click on Find Solutions, and it finds it awfully quick. That means in 40 months they'll both have the same value of 4,000. After 40 months, the graph in red is higher. So after 40 months, the graph in red is higher, and that was the AMD. So after 40 months, the AMD computer has more value to it. On problem 4, it gives you data points for the value of shoes. Air Jordan, and Nikes. And it says let t equals 0 be 1980. Now, I want you to get the linear equation of best fit for the year and the cost of the Air Jordans. Remember, 1980 is year 0, so we'll need 6, 7, 8, 9, 10, 11, 12, 13 for the x's, and these are my y's. So let's go to the linear sheet a second. And back here on the linear sheet, I put in my data points already, 6 through 13, and these were the values of the Air Jordan. And I got this equation and copied it over. And then I went and highlighted those values, copied them. I highlighted them and copied them. Right click and choose copy. Then I went to the nonlinear page. And eventually what they want you to find here is a linear and a logarithmic. So that's this choice here, a poly and a logarithmic. So let's choose that. And the linear I pasted in those values by right clicking, and then I chose paste special as values. And then the what I wanted you to do after that was to get the logarithmic equation of best fit for the Nike shoes. So I went to my logarithmic page. I put in those values. I got my logarithmic equation of best fit, copied them over, copied these, went to the nonlinear sheet, and pasted those coefficients in here. And then, once I get those two equations, I can just click Find Solutions here. It only takes it a second to find these solutions. That's the years. Remember, 1980 was year 0, so 1983.55, they'll have the same, they would cost the same of $67.52. In 17.5 years about after 1980, they would have the same value. But the question actually asked, when, let's go down here to part C, and this is important, find the years at which Nike is the better deal. It's a better deal when it costs less, and Nike was the logarithmic equation. So let's go to our sheet here, and we want to find out when that logarithmic equation, which is the graph in red, is lower than the graph in blue. Well, the graph in red is lower than the graph in blue before the first intersection point, so before 1983.5, and also after the second intersection point, so after 1997.5. If you want to see that intersection point, we could maybe make the increment a little bit bigger here, or start it a little bit closer to that second intersection point. But I'll make this maybe 0.2, and you can see that it's Nike is lower after that second point of intersection. So the answer to this problem is before 1983.5 and after 1997.5. And I think that will do it at this point. We'll pick up at problem 5 on the next video.